my Physics2Lab2, the TapeLab revisited. So in this lab, we're number one going to review lab one so we can kind of have a basis for what our computational model is about and what this lab is about. Then we're going to go through the physics principles used. We're going to go through my computational model and then have a further discussion. So in lab one, the experimental setup can be seen here. We have we put the two tapes together and rip them apart so they're electrically charged. We have one tape on the bottom and then one tape on the top. We're going to lower that top tape until this bottom tape starts to bow up towards the top tape. And so we got that these two pieces of tape are about 0.1 meters. They weigh about 0.001 kilograms. And the distance between the two tapes until this tape starts to bow up is about 4.5 centimeters. At 4.5 centimeters, this tape starts to bow up, but then stays. So from there, we treated this tape as a point charge. We put it in a computational model, and we found that the charge is about 1.5 times 10 to the negative 8 coulombs. So the physical principles that were used in last lab and are going to continue over into this lab is Newton's second law, where the net force equals mass times acceleration. In this case, the tape bows up and then stays stationary and is suspended. So we know that the net force is going to equal 0. And so from there, we can look at our gravitational electric force. And we know how to find our gravitational force, but then we can find our electric force too, because we know that the magnitudes have to be equal to one another since our net force is 0. So now the differing is our new assumptions in this new computational model. We're still going to ignore air resistance on our tape, but now we're going to treat the long tape as though it's a long line of point charges rather than one point charge in the center. We're now going to consider them distributed out in the long rod of point charges, and then we're also going to assume that the point charges are still the charges evenly distributed. Here's our computational model, or my computational model. The initiation of the charge, the mass, the length, all of that is the same as it was in lab one. The new part is number one, initiating these new arrows, and then the iteration to find all the electric fields on all these charges, and then using that to find our big electric force. And so here we can look at our computational model and kind of see what this piece of the code makes. So number one, we have our gravitational force, and that's this arrow pointing down. Then we have our electric field. Now, if this tape is assumed to be positive, this electric field points up as in the model. If this piece of tape was a negative charge, the electric field is actually going to point downward or inward, radially inward, because it would be a negative charge. But here we have those arrows pointing up towards this other piece of tape in that direction of our electric force. So we're assuming that this long piece of tape has a positive charge. And so you can see that the magnitudes of both these arrows are about the same. And so that was found through just plugging in new charges and computationally running it until we found a charge that made it so our gravitational electric force is the same. What was this charge? Well, that charge was about 2.1 times 10 to the negative 8 coulombs. What if you modeled your tapes as a single part charge like in the previous lab, compared the estimated values? So in this lab, we found that our charges is about 2.1 times 10 to the negative 8, versus in the last lab, it was 1.5 times 10 to the negative 8. So there is a difference. This charge is a little bit bigger. So why do these estimates differ? It's all in our approach. The approach for the lab is different, and that makes it so we're getting different charge values, because instead of treating it as a singular point charge, we're now treating it as a long line of point charges. And that long line of point charges is definitely going to be the more accurate value and going to be the more accurate model, because the tape isn't going to be one singular point charge. The tape is a long line of charge distributed across that tape. And so that difference makes it so our model is more accurate, because it's considering the situation as it is or closer to how it is than as a really simplified model as in lab one. Thank you.